Now we are going to discuss about coupling reaction. Coupling. Coupling reaction nothing but dye formation reaction. Otherwise they can ask dye test also. Nothing but what? Dye test. Dye test. These are the very important name reactions. So listen very thoroughly. Okay, very important reaction. What is coupling reaction? Here, the phenols are coupled with benzene diazonium chloride in the presence of base at 273 Kelvin to form para hydroxyazobenzene. Nothing but red is orange color dye. Nothing but dye reaction. Always called coupling reaction. So, what is coupling reaction? Benzene diazonium chloride couples with the phenol in the presence of base at 273 Kelvin to form para hydroxyazobenzene. Nothing but red is orange color dye. Nothing but dye test. Will see the reaction. Benzene diazonium chloride mean. See, this is a benzene ring. See how I am drawing the benzene ring. Diazo, N double bond N. Diazo. Chloride named as benzene diazonium chloride. Benzene diazonium chloride couples with phenol. Phenol mean the benzene ring have one OH group named as what? Phenol. Reaction takes place in the presence of base at 273 Kelvin. 273 Kelvin. So listen, here and all what is there? Each and every cup hydrogen is there. Removal of HCl. Remaining as it is, you are going to write that's nothing but para hydroxyazobenzene. See the benzene ring. Then the N double bond N remaining another benzene ring containing one OH. In which position? Para position, single bond. Okay, that is what? Only single bond. So para position hydroxy is there, named as para hydroxy azobenzene. Para hydroxy azobenzene, nothing but which color? Red is orange color dye. Red is orange dye. Very important reaction, namely coupling reaction. Benzene diazonium chloride couples with the phenol in the presence of base at 273 Kelvin to form a para hydroxyazobenzene. Nothing but red orange dye. So they can ask what is coupling reaction, otherwise dye formation reaction also. Very same answer. The next one is very important reaction, namely Kolb reaction. Very useful for problem part. What is Kolb reaction? Sodium phenoxide reacts with carbon dioxide 400 Kelvin, 4 to 7 atmospheric pressure. It gives sodium salicylate followed by acidification. You will get salicylic acid. Nothing but Kolb reaction. Very important reaction in chemistry in our hydroxyderivatives for problem part Kolb reaction. Not only 3-mark part, problem part also very useful, very important also Kolb reaction. What is Kolb reaction? Sodium phenoxide reacts with carbon dioxide and 400 Kelvin, 4 to 7 atmospheric pressure. You will get sodium salicylate followed by acidification. When you add HCl, you will get salicylic acid as the product. So that what is Kolb reaction? In a benzene ring, ONA, sodium phenoxide. That's the initial reactant. But you know how sodium phenoxide will prepare? Phenol reacts with sodium hydroxide. Phenol mean what? See, this is a phenol reacts with sodium hydroxide. What happened? This OH removal of water. So what is remaining? ONA, benzene ring and ON. Nothing but sodium phenoxide. I don't get directly. Okay. So in a Kolb reaction, sodium phenoxide is the initial reactant. How sodium phenoxide will prepare? Phenol reacts with sodium hydroxide, remove a water molecule, remaining is sodium phenoxide. This named as what? Sodium phenoxide. Okay. Now three conditions you have to remember. One is CO2, Another one is 400 Kelvin. Another one is 4 to 7 atmospheric pressure. Okay. When you see wherever you see three conditions, just you have to recall this is nothing but cold reaction. Which one? CO2 400 Kelvin, 4 to 7 atmospheric pressure. This condition only for cold reaction. So see here in the which group? Which is that? Which group? Hydrogen. Okay. Now this benzene ring. See here, this O, this H. This O, this H combined together called OH where? Here is OH. Okay. Which group we are going to add? COO. CO2 group. COO. What is remaining here? Na. So COO Na. You able to understand? This O combines with this H to form a OH there. OH. So you are going to add COO, CO2 group, and this Na will join here to become a COONA, namely sodium salicylate. Sodium salicylate followed by acidification. When you add HCl, this sodium combined with this HCl, removal of sodium chloride. Now this H will come and join here to become an acid, namely very important acid, salicylic acid. Benzene ring, here is OH group, here is COOH group plus NaCl. It's nothing but salicylic, not cyclic, salicylic acid, otherwise called orthohydroxybenzoic acid. Orthohydroxybenzoic acid, nothing but salicylic acid. Very important name reaction this one. So what is cold reaction? Sodium phenoxide reacts with carbon dioxide, 400 Kelvin, 4 to 7 atmospheric pressure. You will get sodium salicylate. What's the product name? Sodium salicylate. Followed by, when you add HCl, now decomposition reaction takes place, removal of NaCl, so product is salicylic acid, nothing but cold reaction. Okay. The next reaction is Reamer-Tiemann reaction. That also very important name reaction. Reamer-Tiemann. Okay. Reamer-Tiemann. Reamer-Tiemann reaction. After cold, this also very important name reaction. Last year also this question only asked in the problem part. Okay, this is very useful 3 mark as well as problem part. Reamer-Tiemann reaction. The initial reactant is what? Phenol. What? Phenol reacts with chloroform and NaOH. This is nothing but formylation reaction. Formylation means aldehyde group. So you are going to add formyl group in ortho as well as para position. This is nothing but formylation reaction. Okay. So you are going to take very same OH over here. It is OH. Now formylation in ortho position you are going to add one CHO. Very same ortho meta para. In para position you are going to add one CHO. Namely, this is what? Phenol. This is orthohydroxybenzoaldehyde, nothing but salicylaldehyde. Orthohydroxybenzoaldehyde. Orthohydroxybenzoaldehyde. This is nothing but para. Opposite, no? So that parahydroxybenzene, sorry, parahydroxybenzoaldehyde. Parahydroxybenzoaldehyde. Okay. Very same thing. Very same thing. In phenol, we are going to add, instead of chloroform, carbon tetrachloride and NaOH. Now, instead of adding aldehyde group, we are going to add carboxylic acid group, so that your product is See here in ortho position one COOH group and one para position another COOH group, namely orthohydroxybenzoic acid, para-hydroxybenzoic acid. Named as what? Ortho position hydroxy is there, so that orthohydroxybenzoic acid. This is nothing but para hydroxy benzoic acid. So whenever you see this condition, chloroform NaOH or carbon tetrachloride NaOH, this reaction Riemann-Tiemann reaction. That condition, carbon dioxide 400 Kelvin, 4 to 7 atmosphere pressure, meaning how to remember which reaction? Cold reaction. Chloroform NaOH or CCl4 NaOH, mean that is which reaction? Riemann-Tiemann reaction. So phenol reacts with chloroform NaOH. This is a formylation reaction. So you are going to add formyl group in ortho as well as para position. So namely orthohydroxybenzaldehyde and para-hydroxybenzaldehyde is a product. Very same thing. Instead of chloroform, you are going to add carbon tetrachloride. So that phenol reacts with carbon tetrachloride NaOH. Instead of adding aldehyde group, you are going to add carboxylic acid group in ortho as well as para position. So namely orthohydroxybenzoic acid and para-hydroxybenzoic acid the product, both are very important name reaction. Not only 3-mark question and problem but also very important. Okay. Okay. Now after Riemann-Tiemann reaction, next important reaction, namely Thalline fusion test. What is Thalline fusion test? Phthalic anhydride reacts with 2 molecules of phenol. In the presence of corn sulfuric acid, you will get phenolphthalein. That's nothing but Thalline fusion test. That's one of the indicator. Already you used in 11th standard. One of the indicator, namely phenolphthalein. Okay, in this method you are going to prepare your indicator, namely phenolphthalein, that named as Thalline fusion test. Very important test. Thalline fusion test. In this reaction, the initial reactant is phthalic anhydride. So first we will see how to prepare phthalic anhydride from phthalic acid. In a benzene a ring having 2 carboxylic acid group, mean that named as COOH. COOH. This is one of the carboxylic acid. This another carboxylic acid in adjacent carbon, mean that named as phthalic acid. That named as phthalic acid. What do you mean anhydride? Anhydride means there is no water molecule or from the removal of water. So from phthalic acid, we are going to remove one water molecule. The remaining is phthalic anhydride. So that if you remove one water molecule, what is the remaining part? Only O in the middle. Only O in the middle. Okay, I am going to write now phthalic anhydride, so that the O only present in the middle. This is nothing but what? Phthalic anhydride. Now you know very well how to prepare phthalic anhydride from phthalic acid. You are going to write phthalic acid. From phthalic acid, you are going to remove water molecule. You will get phthalic anhydride. Nothing but what? Phthalic anhydride. In phthalic anhydride, I am going to add 2 molecules of phenol. 2 molecules of phenol. I am going to draw like this. This is a benzene, one OH, namely phenol. I am going to take 2 molecules of phenol, so that like this. Here and all you know very well, each and every corner H is there. Clear? This reaction takes place in the presence of concentrated sulfuric acid. Because concentrated sulfuric acid is the best dehydrating agent. It will remove very easily water molecule. That's why, that purpose only you are adding here corn sulfuric acid. Because corn sulfuric acid is the best dehydrating agent. Okay. Dehydrating agent, you are going to remove water molecule here. Okay. So double bond is there now? Double bond. So you are going to make one bond here, one bond there. That's the product. Okay, that's nothing but phenolphthalein. So how to draw the phenolphthalein? This is a benzene. Okay. Here is a C double bond O. Middle one is oxygen. Here is See, okay, double bond is there, one bond here, one bond like this. So both ring is attached in phenol. Nothing but what? Phenolphthalein. Phenolphthalein. This is spelling for phenolphthalein. PHNOL, PH, PHALEIN. Nothing but phenolphthalein. So it's very important reaction. 3 mark part. I think last year also they asked in the board examination how to prepare how to prepare phenolphthalein from phenol. Like they asked me last year. Okay. How to prepare phenolphthalein from phenol. Phthalic anhydride reacts with 2 molecules of phenol. In the presence of carbon sulfuric acid, very important. You have tried. Otherwise, you get only 2 marks. Okay. Phthalic anhydride reacts with 2 molecules of phenol. In the presence of carbon sulfuric acid, you will get phenolphthalein. Very important name reaction. Namely, phthalate fusion test. You able to understand? Very easy one. How you will prepare phthalic anhydride from phthalic acid? You write phthalic acid. Remove water molecule. You will get phthalic anhydride. The phthalic anhydride reacts with 2 molecules of phenol. In the presence of carbon sulfuric acid, you will get phenolphthalein is the indicator. Okay. The next one is oxidation reaction. Phenol undergoes oxidation reaction in the presence of chromyl chloride. You will get quinone is the product. What is the formula for chromyl chloride? Chromyl chloride, CrO2Cl2. Okay. So phenol undergoes oxidation reaction in the presence of chromyl chloride. The product is what? Quinone. Oxidation reaction. Phenol. Oxidation reaction. Reaction takes place in the presence of chromyl chloride, CrO2, Cl2, nothing but chromyl chloride. Now the product is quinone. Quinone means benzene ring, both side double bond. Here also double bond O. Here also double bond O. Nothing but paraquinone or quinone is the product. So phenol undergoes oxidation reaction in the presence of chromyl chloride. Chromyl chloride means CrO2Cl2. This is very important 1 mark question in D block elements. Okay, here also you can learn. Chromyl chloride means CrO2Cl2. Very important 1 mark question. Here phenol is oxidation to quinone. So oxidation reaction. After that, catalytic hydrogenation reaction. What do you mean? Hydrogenation reaction. Hydrogenation means addition of hydrogen. Nothing but hydrogenation reaction. Catalytic hydrogenation reaction means catalytic hydrogenation reaction. Hydrogenation means addition of hydrogen. Catalytic means in the presence of catalyst addition of hydrogen. So addition of hydrogen nothing but reduction reaction. Now reduction reaction takes place in the presence of catalyst, nothing but catalytic hydrogenation reaction. Now in phenol we are going to add hydrogen in the presence of nickel lactic catalyst, that is a reducing agent. In the presence of 443 Kelvin we will get cyclohexanol. Now we will see here phenol. This is phenol. Hydrogenation, we are going to add hydrogen. I am going to add 3 molecules of hydrogen. Reaction takes place in the presence of catalyst, so that we are going to add nickel lactic catalyst. How much Kelvin? 443 Kelvin. Now what's the product? Assume that in benzene ring mean each and every carbon atom bonded with how many hydrogen atom? Let's assume that the benzene ring, so that alternate double bond is there. So just imagine that each and every corners are carbon. See this carbon 1, 2, 3, 4. Okay. See here 1, 2, 3 bond remaining one is what? Only one hydrogen atom is there. So simply we are putting one benzene ring mean that indicate each and every corner containing one carbon and one hydrogen atom is there. C6, CH, 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 CH likewise. Then only molecular formula will satisfy C6H6. But here I am going to add 3 hydrogen molecules, so that totally 6 hydrogen atom. Where I will add? One here, one here, one, two, three, 4, 5, 6. So that I am going to remove these three double bonds. Here, so you know the difference between these two. What is this? Otherwise, instead of putting double the electron cloud, what is the difference between these two? Both are equal? Both are equal? Not equal. This is a benzene. Nothing but cyclohexane. There is no double bond is there. This molecular formula CH6. This molecular formula CH12. Because here only one hydrogen atom is there. But here each and every carbon two hydrogen atom is there. Then only carbon valency will satisfy. Here, so these are not equal. Clear? So that when you add 6 hydrogen atom, benzene ring become a cyclohexane ring, then one OH, namely cyclohexanol. Cyclohexanol. What is the difference between these two? Here the alternate double bond is there, but here there is no double bond. This indicate here only one hydrogen atom is there, but here each and every carbon, two hydrogen atom is there. Clear? So named as what? Cyclohexanol. So phenol undergoes catalytic hydrogenation reaction in the presence of nickel acts as a catalyst at 443 Kelvin. The product is what? Cyclohexanol. Okay. The next one is condensation reaction. Condensation reaction means surunguradhu. Phenol condense with formaldehyde in the presence of sodium hydroxide. The product is para-hydroxyphenyl methanol. Para-hydroxyphenyl methanol. We'll discuss now. That's nothing but Lederer-Manasse reaction. Condensation reaction, nothing but what? Lederer-Manasse reaction. Now, Lederer-Manasse condensation reaction. This is one of the condensation means condensation reaction. In condensation reaction, the name reaction is what? Lederer-Manasse reaction. Okay, Lederer-Manasse. Lederer-Manasse reaction. Okay, what is Lederer-Manasse reaction? Phenol. Okay, this is a phenol. You know very well. In anywhere you can put one hydroxy. So here I want to add here is hydroxy group. It's named as phenol. Okay. Reacts with formaldehyde HCHO. HCHO is formaldehyde. Reaction takes place in the presence of base NaOH. NaOH. Listen ma. HCHO is formaldehyde. You can write like this also. One carbon, two hydrogen atom is there, one O. Okay. Formaldehyde HCHO is formaldehyde, but you can write like this also. CH2O. Clear? Okay. So I am going to rub this one. Instead of writing HCHO, okay, CHO or CH2O. See here, in para position and all, each and every carbon atom or hydrogen atom is there. I am going to add this group in this position, so that see already what is present in a reactant here is one OH group is there. See here in H is there. CH2OH. Clear? One carbon, two hydrogen to become a CH2 and OH. So here in para position, I am going to add CH2OH. What's the name of the product? In para hydroxy is there. Para-hydroxy phenyl methanol. Para-hydroxy phenyl methanol. AHANOL because alcohol. Okay. Para-hydroxy phenyl methanol is the product name. So what is Lederer-Manasse reaction? Phenol reacts with formaldehyde. The presence of NaOH, it goes para-hydroxy phenyl methanol is the product. This is one of the condensation product, namely Lederer-Manasse reaction. Okay. Suppose in presence of excess formaldehyde, a three-dimensional polymer called paclite is formed. So what is the paclite mean? It's a How what is the backlight? How it will be? The three-dimensional pattern. Okay. Ladder excess formaldehyde mean see here. This is one of the phenol. This is a another phenol. In between fully what? CH2. Here is CH2. Here that everything everywhere what? Here is CH2 bond. CH2. CH2 like this. Named as what? Backlight. Yeah, when you add excess formaldehyde, what you get? You will get a polymer product, namely backlight. So, what are the uses of this one? Phenols are used, very important use. Industrial is very useful one. Not only industry, in a prepared dye, you are now only prepare no in coupling reaction. Benzene diazonium chloride coupled with phenol, the presence of base at 273 Kelvin to para-hydroxyazobenzene, nothing but red orange dye. So dye preparation also is very useful one. Dye preparation when applying drugs, plastics, explosives and pesticides. When preparing these things, phenol is very useful one. Not only this one, phenol is very useful in antiseptic and germicide. The use some soaps, lotions and all. It's a very important use when you preparing dye. Phenol is very useful one. Okay. So in this lesson, the important name reactions when you discuss now on the coupling reaction, Kolb reaction, Riemann-Tiemann reaction, Thalen fusion test, Ladder-Menese reaction, Cotton moment test, what we discussed already. Why alcohol is not a suitable solvent for Grignard reagent, then Lugos test, Victor-Meyer test, catalytic hydrogenation reaction, iodoform reaction, chloropicrine preparation, this one, picric acid preparation. Okay, these are very important name reactions. You have to be very thorough in this lesson. Okay, then you can say very easily nice marks. Okay, thank you, students.